Hello, can you guys hear me? Marlene, Ike, nobody else? I think it's the three of us. But anyway, let's wait for Delia, so I can answer her questions. Can you hear me? These were questions that she sent me, and I thought I'd address them first, and then I can get into the midterm exam. If there's any questions in the midterm exam, that the one I specified, this was October 19 last year. If there's any particular questions you want me to answer on there, let me know, okay? So have a look through that while I'm answering these questions. Okay, great, Chloe. Okay, so I think it's 4 of us. But let's get started. I'm going to go to Midterm Exam Review I, question 19. Okay, question 19. All right, so let me give those people who haven't had a chance, let me give you a few minutes to try it. Okay, so I'll give you a minute. I don't know how to settle that. Okay, so try that problem. So you need to assign the given correlation coefficients to the scatter plots. This is easy, right? We'll find out. Okay, so give me your answer, and then I'll tell you my answer. Okay. So R, we know, is between -1 and +1. The closer the observations are to fitting on the line, the closer we are to the extremes of -1 or +1. The sign tells us the relationship, the trend of the relationship. Is it a positive trend? In other words, do the variables reinforce each other when one goes up relative to its other values? Does the other one go up? Or is it that when one goes up, the other one goes down? Okay, so that one would be positive, and then if they're opposite in their response, then that would be negative. Okay, so in the first one, what we have is a negative relationship in A. So this is a negative relationship, so this has to be the only negative option, which is negative 0.95. So we're down to C and D. For B, B is a positive trend. So, but it's not perfect. It's not that close to one. I mean, it's not that close to the line that they scatter plot is demonstrating. So, that would be, okay, so this is the thing, right? So you have to choose between these two. And it looks like I would pick 0.76. So even without answering, without looking at C, I know the answer should be C, and most of you got it, so that's good. But just to look at the third scatter plot. In the third scatter plot, now these are just scattered all around. They're not fitting close to a line. It looks like it's a positive trend. If I forced a positive trend, if you can imagine, visualize a line through those points, but it's they're very scattered, so that's going to be closer to 0. So the answer, I would say, is C for this one. Right? Questions? Now, the question to you is, was it marked different in the solutions? It should be C. Okay, so let's continue. Let's look for the other problem she asked for. Okay, so now I'm going to get out of here and go to the Review II. Yeah, the answer is C. Marlene. Okay, so I'm going to go to 2, and here you asked me to look at 3 questions, 24, 25, and 26. So, okay, more scatter plots. Okay. So question 24. Yeah, so we're going to refer to this graph for the next 3 questions. Okay. Should I leave you? Should I leave you to try that one first? Okay, so you try the first one. I'll give you a couple of minutes. Delia, don't be scared by scatter plots. Okay, so let's see. Let's get in charge of this. So there's just 2 things you need to think about. when you look at scatter plots and when you think about regression, direction and strength, right? R tells you the strength of the relationship, how those observations hit on a line or fit on a line. And direction is whether it's going positive or in a negative direction. Is the slope up or is the slope down? If its slope is up, it's positive. If slope is down, it's negative. So what's happening here? For 209 students, the following is a scatter plot of the students' heights versus the span of students' writing hand. Okay, so measured from the tip of the thumb to the tip of the, so if you think of holding your hand out, spreading it out as much as you can, the tip of the thumb to the little finger, tip of the little finger on the spread of the hand. Okay, so the correlation for these data, the R is 0.6. So it's it implies that you can't predict one perfectly from the other, but it does look like when one is big, the other one is big, or one is high, the other one is high. Okay, so when a person is tall, they have a wider span of hand. So they give you the regression line, and they ask you is to identify what this is. What kind of data is this? What's your answer? Okay, so this, now you're putting together, these are terms that you learned in the first unit. Don't be intimidated. Students get very intimidated when we mix the units. Like, it's like you don't think you can mix colors, but of course it becomes more beautiful when you do mix. You see different things. Okay, so this is a synergy of concepts. Let's see. It's not an experiment, right? This is not an experiment. There was no treatment. It's just an observation that these things are doing. These are the measures of people's hands at the same time as we're measuring their height. So this is just an observational study. This is C. A causal relationship. Does your height or your span of your writing hand cause your height? I see why you might be confused. We can never, from a correlation, imply causal relationship, okay? We can't imply that one causes the other just by looking at a scatter plot. There would have to be an experiment conducted to be able to speak about cause, or some measures taken to control for other factors that may be influencing student heights. So this is not a causal relationship. This is an observation study. These are the results of an observation study. This is an example of an observation study. Yeah, I think it's C. Can you confirm that it's C? Because I can't turn the page. Maybe I can check. You can confirm below that the answer is C. Okay, so the answer for me is C. I am going to go up, or I'm going to go to the next one. All right, so the next two problems refer to the same scatter plot. If the unit of measurement for span of the writing hand is changed to inches, okay, so what happens? Okay, so what are we doing? If we change centimeters, okay, so they went from centimeters to inches. What will it influence if that's the case? And then the 26, what is the R square, right? They're asking for the percentage of variation in height that is explained by the regression of height on the span of the writing hand. Remembering that this is, we always say Y versus X. So when it is height on the span of the writing hand. Okay, so let me give you a minute to try those. Okay, so what we're doing here, keep in mind, the question is asking if you change if you change the span of writing hand from centimeters to inches, what you're doing is you're changing the values of x. Not the relationship between the values, okay, but you're changing the values themselves. So what's going to be affected, if you're thinking about the correlation coefficient is an index. You think of it as an index. So because I'm not changing the values, the relationship between the values of the writing hand, just the values themselves, if you know what I mean. Because correlation is an index, and I'm standardizing the covariance, whatever I've done by changing from a metric or a measure of centimeters to inches, it's going to be adjusted for when I standardize, okay? So the index won't change. The correlation doesn't change because of that. The values are different. The slope will change so because of that. But the intercept won't either, because you're hitting, this is affecting the y-axis, okay? So because you're only changing the values of x, you would change the anything if it was going through the x-axis, but the line's going to go through the y-axis, and then in that case it's not going to change. So the slope will change. The slope will change, but the correlation coefficient won't, because it's an index. And it doesn't matter if you convert to a different measure, but that the values of the writing hand, are still related the same way. That won't change correlation. And it won't change the intercept, because we're changing the values of the writing hand. We're not changing the values of the span of the writing hand. We're not changing the values of the height. Okay, so that's really confusing, I guess. There's going to be, and if you check out the other exams, there's always a question kind of like that. So keep asking me, and I'll keep trying to clarify how you think about that type of problem. So the answer is D. You are right, Delia and Isadora. All right, try 26. I'll give you a minute or two. Okay, what'd you get? So what is R square is the question, really. That is the coefficient of determination, or the percentage of variation in height that is explained by the regression of height. So r squared, what would r squared be? R was 0.6, so 0.6 squared would be should be C. Are you guys saying A? The 0.6 squared? Did I, oops, let me see, 0.6 squared. Do you guys see that? Point 0.6 squared. All right. YA. Yes, it's C. 0.6 square. Square 0.6. How do I know it's 0.6? Go back to the problem. We were told that R was 0.6. Okay, so then that's R, so R squared is 0.36. Because you know that it's supposed to be squared because it's the, hold on a minute. You know it has to be squared because it's the coefficient of coefficient of determination. The coefficient of determination is r squared. How do I know it's a coefficient of determination? Because it says, it asks for the percentage of variation in height that is explained by the regression of height on the span of the writing hand. Or it would say the percentage of variation in height, so the percent of variation in y explained by x. That's the coefficient of determination. So you have to check that to know that. That was in the notes. Let me see if I can go back. I'm just going to find the coefficient, the explanation. So as I explained when dealing with Unit 3, what I did was made a list of all the things you need to know, okay? So they're listed here. These are all the things you need to know how to do. All right? And number 9, what proportion of variation in y is explained by x? In other words, what is r squared? Okay, that's what all of that is about. And that's on page 9. And I explained that so these extra pages are just for completeness. Alright, I have a bunch of examples. So these are all examples. Now that I'm looking at it. Let's see. Maybe I did. Oh yeah, it's up there. I have it right up there. Okay. What proportion of the variation in y is explained by x? What proportion of the variation in y is explained by x? In other words, what is r squared? This is called the coefficient of determination, and it's just r squared. So r goes from being an index into being interpreted as a percentage. Okay? So whenever I ask that, what is the proportion of the variation in y that is explained by the variation in x, or that is explained or determined by the least squares regression? Sorry, by the regression. Okay, so that's how you do that. Any questions about this? So I think we've done all of them. We've done all of them that Dilly asked for. Okay, so the answers were C, D, and C. Okay, so let's get on to the other midterm, well, the actual midterm from last year. So you can find that on the Moodle page in the midterm section. The exam, I haven't made the exam yet, but it'll probably be just like the midterms that we're reviewing, okay? So 30 questions. I'm not going to say exactly, but it's going to be similar to those exams that I posted. So this is the exam from last year. How many questions were there? 40. Okay, so it could be 40. From 6 to 8. Yes. Yes. From 6 to 8 p.m. All right, so let's do a couple. I don't know if you have it in front of you. Maybe you guys can ask me which ones you want in particular, so I don't waste your time. So pick some that you like. Maybe I'm going to make it a little bit bigger in the screen. Yep. Anyway, I'll leave it like that. Okay, 1 or 2. I know, Marlene, you just got to practice. How many exams have you guys done of the midterms? If you're just starting, what I'm going to do is I'm going to pick one midterm a day and just do problems, get you going. All right, I'll try and do the harder ones, and then you'll have a sample to review. Then maybe you can hear my voice in your mind, helping you work through the problems when I'm not around. And you're going to be able to use your materials at home, but please do study because time is tight. It's 2 hours. You don't want to be rustling through papers, right? You want to know the answer and maybe just check a couple of things. That should be your approach to completing the exams. What you can do is you can send me, after you finish the exam, I will give you 15 minutes to upload to me the solutions you worked on. Okay, so I'll give you, well, let's say 10 minutes. I don't want to draw it out too much. So I'll give you an extra 10 minutes to upload the calculations you made. So let's say you picked the wrong option, but you feel like you deserve some credit for your efforts. I'll have a look at that. Okay, so send me your worked out solutions. Try and be neat as you can. Number the questions clearly, and I'll see what I can do. You still have time. It's still a week away. Just work on the midterm problems, okay? Okay, so let's see. You wanted me to do 1 and 2, Delia, or you mean review 1 or 2? I'm not sure what you meant by that. I turn it like this. Does it flip? Okay, I'm just playing with my iPad, trying to get the right image. Did that work? Kind of flipped it. Okay, so let's see. I don't know what those red lines are doing. You can see the red lines too. Not sure about those red lines. All right, so let's see. Is there a relationship between marijuana use and use of other illegal drugs? A survey was conducted in the United States and 9 countries in Western Europe. The percentage... Somebody's asking me, which of the 2 midterms? No, I'm solving... This is the midterm I listed, Midterm Review I. Midterm exam, October 19. It's in the description of the... I put it in the description of this stream. October 19, 2019. Okay, so why don't you guys draw that problem? Try questions 17 and 18. If there's anybody else here who has not texted their name, put your name in the chat so I know you're watching. All right. Post your answers when you think you've got it. Hi, my technologist. Jan's here. So try these problems 17 and 18. I give you 1 more minute. Is it slow? It's just me. I'm pausing a lot. I don't know that it's delayed so much. Or maybe I'll work it out. I'm not sure why that would be. Okay, so for question 17, let's go through each one. Okay, a good prediction for the percentage of teens who have used other drugs in Scotland, where 53% have used marijuana, is 2819. Okay, a good prediction for the percentage of teens who have used other drugs in Scotland. So, okay, so what they're doing is they're giving you a value that's not there, right? And they're asking you to use the line to make a prediction. That's the idea of regression. So can you use this line to make a prediction, and what would you get in making the prediction? Don't get thrown off that these are percentages. These are percentages. But just remember, percentage is like a unit. Don't get confused. Don't have to put in decimals like I did yesterday. Don't have to put in decimals. Just use the numbers as they are. Just be consistent about it. All right? What did they do here? Percentage. So, if we were to say, if we were to use this result, let's be clear, the percentage X of teenagers, so let's be clear first. First step is to label X and Y. Okay, so that's the percentage used, and Y is other drugs. Okay, so we have that information. And for this one, you have to go through each one and find the true statement. All right, so we're going to go through each of these. For the first one then, if for Scotland, you know that 53% use marijuana, what you have to do is put this in here as X and see what you get for Y. If you put this in as X, what Y do you get? If it's not 2819, then that is not the right answer. What do you get when you do that? If you put in 53, put in 53 here, and then minus 2.55, do you get 28.19? For B part, it says about 79% of the variation in other drug use can be accounted for by its regression on marijuana use. You can check this, as Heike mentioned, you can check this by taking the R and squaring it. Is 0.89 equal to, is R squared equal to 75? That's how you figure out if B is right. So that's true. Okay, so B is correct. But isn't A correct? What about A? Why is A incorrect, Isadora? So for A, if I was to do what I said I would do, I take negative, sorry, I take 53%, I multiply it by 0.58, and then I add negative 2.55. So this is huge. So you have to take 0.58 times 53 and then my goodness, it's not easy. I can't get back in there. So that's what that is, right? So 0.58 times 53, but you have to add at the beginning negative 2.55. This is awkward. What happens if I do this? This is so hard. I thought I would use these equations. Oh my goodness, so messy. Okay. Okay, so that's what you add. You add together. If you add that together, you put it in the equation. Okay, so I lost everything. Okay. So that's what you're going to do. You plug in 53. When you plug in 53, you get 28.19. So why is B the right answer, which it is, and A is not the right answer? This will give me this value, 28.19. The answer is, the reason why A is not the right answer, okay? A is not the right answer because 53, if you look at the range of values for marijuana, which is our X, the range of values does not include 53. Okay? We say 53 is outside the range of values, and applying this line for a value of X that is far outside the range, so we can discuss what is far, but in this case it's sufficiently far away. It's outside the range of these values, so that the line doesn't apply. Okay, the line doesn't apply. Just because there's a relationship, this is the what I'm drawing right now is not necessarily the scatter plot of this, but let's say you have a relationship that looks like it's going up like that, right? Let's say you have a relationship like that, but just because that relationship exists in this range of values doesn't mean it's going to exist out here. It could be that something else happens out there. It just could be that the relationships change, or they tap out, or they plateau. Okay, it could be that if there are values out here, they end up just being flat. If you can see that. Okay? Or they could trend down. We don't know because we don't have data out here. So instead, we avoid that. We avoid using lines, prediction lines, outside the range of the data. So that's why A is not the right answer. B is the right calculation. You do get 79% when you square 0.89 for R. So B is the right answer. I didn't even look at the other ones. 41 is not out of range. Hi, Q. 41 is not out of range. Out of range, 53 is pretty far. And you know how you know 53 is pretty far? Because B is the right answer. So because B is the right answer, A is not going to be the right answer. Okay, so when you get these options, yeah, it's a good question. Which is a good question, Marlene? My question, or my comment, or this question, or Heike's question? Anyway, 41 is not out of range. It's right there. It's next to the 40. So it wouldn't be considered far out of range, okay? All right. Any more questions about that one? So I'll just save that as question 17. Let's look at 18. Oops, I lost it. So let's look at 18. What does 18 say? Okay, what is the value of the residual? You guys can do this. the value of the residual for Denmark. So using the equation, remembering what's residual. Residual is the observed for Denmark minus I'm debating what to do. So observed minus predicted. What's the observed for Denmark? You have to go back up and look. What is the observed for Denmark? The observed for Denmark. So you can only do residual for the observed values. You notice Scotland wasn't there. Scotland wasn't there. That's why we had this discussion about we had to plug it in and find. That would be predicted for Scotland. But to calculate a residual, it has to be there. Denmark is there. Denmark is 17. That's the x. Remembering this is always x, y. I always put those labels in to avoid confusion. So Denmark's 17. So at 17, what do I do? That's 17. So this one is 17. And then the predicted, sorry, what am I saying? No, back. Not, x is 17, right? That's what I figured out. So x is 17, and what else? What is y? X is 17, and y is 3. So we have x is 17, be clear in your mind. X is 17. When x is 17, y is equal to 3. So which one do I want? Well, when I'm calculating the residual, I'm calculating the residual based on y. So y observed is 3. That's what I use. And the predicted one I'd have to calculate. So y predicted, I would calculate again using this line. So the predicted for when x is 17 is what? So that's what we want to calculate it. Y predicted when x is 17. And you put it in here. Negative 2.55 plus 0. I'm going to run out of space. Let's do that again. Y, where x is 17, is equal to negative 2.55 plus 0.58, this times times 17. Okay, so you multiply these first, and then minus 2.55. And what do you get? So this is y observed, this is one is y predicted. Sorry, I don't have a stylus. I'm using my finger. So using 17, you get .31 is correct. So y observed is 3, and y predicted, that's my hat, y predicted, no, that's not working. Lots of editing goes into this stuff. Oh my goodness. Okay, y, oops. Y predicted is 7.31. It's terrible. Okay, so then what you have to do this. So all you've done is you calculated the predicted value, you have the observed value. This is the observed. That's the predicted, and you have to subtract observed minus predicted. Always LMNOP, observed minus predicted. It's alphabetical order. All right? By doing it this way, it ensures that your residuals on top of your regression line are positive and your residuals below the regression line are negative, right? That's why we subtract observed minus predicted. So altogether, observed minus predicted is negative. Observed. I'm here, I'm just checking something, if I have to tell you because you think I'm buffering. Okay, negative 4.31, right? So that's the answer. The answer is D. It's a negative. Isadora. Don't skip steps, Marlene. Okay, there's lots of steps it seems like, but if you practice, keep practicing, it doesn't seem so onerous, not so difficult. Okay. All right, so it's 6 o'clock. Do you want me to continue? Do you want me to do anything else? Do you have to leave? I guess today is our class day, so you shouldn't really have anywhere to go. Do you want me to do a couple more? Let me know. There's 8 watching. I think I'm one of them. So if 3 of you want me to stay, I'll stay. Just write stay. If you have to get going, and the answer is negative 4.31, Marlene. You want me to stay? Chloe, Isadora? Okay, we'll do some more of these. I only did one, really. Okay, so let's see. Okay, I'll stay a bit. Let's see. All right, so which you want me to do more regression or other stuff? Let's see. Let's do, okay, so we did a lot of regression today. Let's just do a little bit. We'll start from the beginning. Let's do some GDS. How about this one? Okay, so this is number 2. More regression. Hey Kay, did you watch my video? I have videos. I have all my videos, regression videos, show you how to compute the equation of a line with 2 points. Do you want me just to do it again? Because it should be there. If you need to compute, if you have to compute the equation of a line with 2 points, first you use the points to find the slope, and then you follow what I did in the video. Okay, you use the points to find the slope. How do you find the slope with 2 points? Change in y or a change in x. The point is, for statistics, you only really need to do it with a slope and a point. Okay, Heike, is that all right? I'll just make some notes here. If you want the slope, try to do something here. Lots of flashing. I'm just working to expand. I want to expand this, but I don't know exactly how. Maybe that worked. It just seems a little bit small to me. That work? Yeah, Heike, I explained how to compute the equation with a given slope because that's all you're going to do in statistics. Usually you're going to get the slope because you calculate the slope using the formula. The formula being, let me put a blank page in here. How do I do that? So, R equals change in what? R, sorry, what am I thinking? R, so slope B equals change in y over change in x, right? That's what you usually do. And so you identify one point and call it point 1. You identify another point and call it point 2. And you calculate y2 minus y1 over x2 minus x1. But we don't need to do that because we are getting the slope from something else to make our line. We're getting the slope already in regression. The slope, I explain, comes from a result of calculus, okay, that finds that the slope is like this. Okay, this is the slope in regression. Now what's the difference? The regular slope just has points that all fit on a line, so you can take any 2 points and calculate the slope between them. In regression, we have many points, all right? And the solution to what is the slope, in other words, which is the best line with the best slope, the result is this one. This is the best slope. This is of the best line, okay? So I mentioned in the notes and I think in the video that you should remember this formula as R, Y, S, X. So always remember when you're calculating this, oh, I have to make it a little bit smaller. Move it up a bit. When you're calculating the slope, R, S, Y over S, X, remember y is on the top and x is on the bottom, okay? And this actually, you can remember the mnemonic term, I guess you would call it. This is risk, okay? And in terms of finance, we use this calculation of B, the slope of the best fit line, as the as a measure of sensitivity. And we use it to measure the sensitivity of a single stock returns to the activity in the market as measured by a market index. Anyway, that's more information than you need to know, but just that risk will help you remember. Remembering the word risk will help you remember that you put the sy on top of sx, because y comes before x. Okay? So you don't need to know how to calculate the slope. You don't need to calculate the equation of a line with 2 points, because maybe the 2 points of the regression don't even lie on the line. They might just be around the line. So you're not going to use this approach. In statistics, we use this approach for the slope. Okay? And then from there, you get the intercept by using together the point x bar, well, I guess you're not going to see that. Using the point with this slope. Which point? The point that you're going to use, remember, is x bar, y bar. X bar, y bar will lie on the line because if you remember, the balancing point of the distribution is the mean. Now we're talking about two variables, and the balancing point of either of them are their means. So since the mean is the point, it's the value closest to all the other observations, the least squares regression line must pass through this point. Okay, it must pass through this point. So there's your point, there's your slope, and you can find the equation of the line. Okay? Oh, what else? You guys are getting good at asking questions. So let me, I don't want to cancel this. I just want to go back to my picture. Okay, so this was the question we're going to look at. Considering the following frequency distribution for exam scores of a class of 127 students, which of the following is true? So what you have are this is just showing you how many observations in each class, right? Class meaning like in each interval. And what we see is that most of the observation, a good chunk of the observations are here and here in the 70s through the 90s. And there's just there's just a few out here. So what kind of distribution is this one? Well, you have most of the values on one side and then just a few over here. This is not symmetric, right? This is the other kind. It's asymmetric, or we say it's skewed. And because there's just a few observations on the low numbers, that is on a number line that goes from low to high, that is called a left skewed distribution. Okay, so the skewness is to the few values. There's a few values over here. So there's a few on the left. That's why it's left skewed. Now, when it's left skewed, remembering the relationship between the mean and the median, the mean is sensitive to the outlier. So that means the mean will be drawn towards You see me? You can see me? Sorry, I'm supposed to talk in here. I have two computers going. That's why I get confused. Okay, so my iPad is pretty much dead. I mean, it just lost the battery. So I have to recharge my iPad. I won't be able to use it right now because if I turn on all those features, it's an older iPad. So if I turn on all the features that I need, it just will use all the power up of the battery and it will just crash again. So I'm going to have to stop here, but I'm going to encourage you, finish that exam. Do that exam tonight. You can ask me questions. You can email me questions so you can finish it the best that you can. And then tomorrow we'll review your questions, okay? So let's do that, and I'll see you on Friday. My computers are fine. It's just the battery. Like all the things that I'm running are consuming a lot of energy. I have to turn off a lot of extra things at the same time, and I seem to have forgotten to do that today. All right, so we'll see you tomorrow. I'm sorry. I hope that was all helpful, and we'll continue tomorrow. Bye.